This is lesson 2b. We're going to solve quadratic equations by factoring. So let's take a look at what a quadratic is. So when we're in general form is ax squared plus bx plus c equals 0. So now what we're doing is we're taking each of our expressions and putting an equal 0 on the end to make them into an equation. Okay, that's all we've done. Is we've taken our expressions and we're adding equal 0 to the end. So that just means now going to be an equation. Okay? So quadratic form is a parabola shape. Okay, the parabola is a shape. It either looks like a U or a hill. Okay, so it looks like a U or a hill. Which of the following are quadratic? So if we're looking for a quadratic equation, what specific things are we looking for? There's something very, very specific we need to be called a quadratic. Okay. Yeah, something so we can FOIL. What else? Oh, involving 4 terms? Or 4 things? Yeah, you're close. It means variable. What else? What about the exponent on the variable? It needs to have
squared x.
That's it. We need to have an x squared. The minute you see x squared, you know it's a quadratic. But x squared has to be the highest exponent. So over here we've got an x cubed. That would be a cubic function, okay? It's not, squared is not the highest, cubed is here. So this guy's got an x to the 1. That's not a quadratic. You need to have an x squared as your largest exponent. So these guys are yes quadratics. These last two are not, okay? So we need to make sure that we have an x squared as the largest exponent on the x. So when we talk about equations and answers of equations and solving them, what we're actually supposed to actually look for is we're looking to find x-intercepts. So everything we are doing is based upon an x-intercept. So whenever we're asked for a solution, we're asked for our x-intercepts. So x-intercepts have 4 different names. So it could be called our x-intercept, or it could be called a solution. It could be called an answer, and it could be called a root. Solution, answer, and root. Okay, that's another name for x-intercepts. And they're also called, one more thing, it's called the zeros. They use the word zeros because on the x line, the y number is 0. It doesn't move up or down. So the x value is your x-intercept, the y value is a 0. That's what they call it, the zeros. So we have lots of different names for x-intercepts. So if we take a look at this equation right here, we're seeing this parabola shape here, and it's crossing through specific numbers. What do you notice that it crosses through on the left-hand side? -3. What about on the right-hand side? +5. Well, what do you notice about the brackets, though? Look very specifically inside the brackets. They're the opposites. So that's something we're going to figure out. These are called the factors of the equation. When you graph it, it's called the solutions of the equation. So the actual answers or solutions are the graph parts. So the graph equals the solutions. Here in the equation, those are the factors. And the factors and solutions are opposite sides. They're always opposite. So factors and solutions always opposite in terms of their signs. Positive or negative, they're always opposite. So in the brackets will always be backwards to what you see in the graph diagram or what you ask for a solution. So on the right-hand side here, we'll see it touches -4 this graph, and it touches +2. And what do we notice is in the brackets here? The exact opposite. Okay? So it touches +2 and -2 is in the bracket. Touches -4, +4 is in the bracket. Okay? So same thing, they are opposites always. Okay? Alrighty. I'll give you a minute to write that down. Okay, so when we're talking about solving quadratic equations, the equation with two binomial factors, that's those two brackets, we need to use what's called the zero product property. So we make each one equal to 0. So either one of them equals 0 or both of them equal 0. Because what's 0 multiplied by anything? 0. So it doesn't matter if both of them are 0. It matters if one of them are 0. But what we try to do is we try to always make them each equal to 0. And then we literally just solve for the answer. So, for example, up here, they have a, or x plus a, and x plus b. So what they've done is they've made x plus a equal to 0. Then what they did was they took the a to the other side. How do you remove a positive a? Subtract it, so we become the negative a. That's how they got this. X equals negative a. Okay? Over here, same thing. X plus b equals 0. And literally solve the equation. Move the b over, so it becomes a negative b. So that's how, this is our generic way of showing how the process works. And it's called the zero product property. Okay? Something has to multiply to give you a 0. Okay? So, how do we check our answers? How do you always check your answer? Starts with the letter S. So, substitute. Good. Just like we did with our radical equations, we had to substitute our answer we got for our equation into our left side, right side to see if the left side equaled the right side. That's basically what this is saying. We have to substitute each x value into the equation to see if the brackets equal 0 when you multiply them. So when you multiply, you always want to get an answer of 0. And if you do, then that means that that number is a factor of that equation, if you get an answer of 0. Okay? It means it works. All right. We're going to take a look at the bottom and do exactly what it is. And I'm going to show you the quick trick after we do it the long way. Okay. So, we've got an equation here. It could either be y equals or just equals to 0. It doesn't matter. The reason we threw y equals out front was just so that we notice that we can put it into our y equals in our calculator. Because we can also graph it to see where it touches the x-axis. And that's what our third lesson is about. So here, solving by factoring, we want to find out where does this one touch the x-axis. The way we do that is we create each equation equal to 0. So I'm going to say x minus 4 equals 0, and then I solve for x. So I'm going to take my 4 to the right, plus 4, plus 4, so x equals 4. That's one possible solution. Then I'll do the same thing with x plus 7. So x plus 7 equals 0. Take my positive 7 to the right by subtracting it. So I get x equals negative 7. So I get two answers. And what we're trying to do is we're trying to make each bracket equal to 0. So basically what I say to you is this. What makes the first bracket equal to 0? What can I put in for x that we subtract 4 to make 0? Well, we got an answer of 4. If we put it in there, does 4 subtract 4 give us 0? Yes, that's what we're trying to do. What makes this bracket 0? What plus 7 gives me 0? Negative 7. That's what we got here. So essentially, we're trying to make our brackets equal to 0. Okay? Now, here's the quick trick. What do you notice about the sign of the 4 in the bracket? Right. He's a negative. This guy comes out as positive. This guy's a positive. He comes out as negative. So all you've got to do, you don't even have to show these steps. If you understand that concept, all you've got to do is reverse them. And you can solve for x right away. What's the opposite of negative 8? Positive 8. What's the opposite of positive 7? negative 7. We just solved letter B. Okay? That's all we're doing. Is making it, it's making it equal to 0. But what if you get a number in front of x? Okay, if you get a number in front of x, what's going to happen is your answer is going to become a fraction. And I'm going to show you why. So I'm going to do it the long way. 2x plus 5 equals 0. Then I move my 5 to the right. So I subtract 5, subtract 5. So I get 2x equals negative 5. Then you divide out the 2, and look what I've created. I've created a fraction on the right. And that's what it becomes. So x is equal to negative 5 over 2. Let's try the quick trick with this one. I'm just going to erase this stuff so I have more room to write. So the quick trick with this guy would be like this. And this will always be true. So what is the opposite sign of the 5? Negative 5. Good. Who's in front of x? 2. Slide it on the bottom. That's all you're doing. Okay? That's all you're doing. So x equals that. What would make this bracket equal to 0? What subtract 3 equals 0? 3. Good job. Just do the opposite side. So we've got x equals negative 5 over 2, and x equals positive 3. And those would be our 2 solutions for that question. Okay? So whenever you've got a number in front of x, he's going to slide under and create a fraction. But you do the same rule. You do the opposite of the guy without the variable. So opposite side. All right. Let's take a look at these guys. These are ones we have to factor first. And these are the ones where they're showing us the wording. We're not done, guys. Please don't pack up. So, right here, they're called solutions, answers, x-intercepts, proofs. Okay, all of them. And there was one more, zeros. They're also called zeros. So we can't forget, they're also called zeros. Okay, so the first one we have to factor. So if we do a diamond on the first one, negative 56 with a positive 1. Well, that's going to give me 8 and negative 7. Do I have a digit in front of x squared other than a 1?
Wouldn't it be negative 8 and 7? So that you get...
No, negative 8, positive 7 will give me a negative 1 here.
Yeah.
Okay? 8 subtract 7 is positive 1. Okay? Alright, so now let's put them in the brackets. You're going to open 2 brackets. So I open 2 brackets. X goes first. Then I'm going to throw in my answers on my wings. They go right in. So plus 8 minus 7 equals 0. So that's I'm only half done. I have to now actually pull them out of the... Okay, so now we're just going to pull them out of brackets, as we mentioned. So we're doing the opposite sign. So this guy comes out of brackets as x equals negative 8. And this guy will come out of brackets as x equals positive 7. So these would be our 2 solutions for that question. Okay, let's take a look at B here. So we're just going to erase our work here on the left. So if we look at B, first of all, we always have to GCF. So I can divide out 5x from both of them. So I'm going to have 5x and then x minus 4, all equaling 0. So whenever we get an x sitting all by itself, it's not in a bracket, we make it directly equal to 0. So this guy's going to become 5x equals 0, divide up 5, x is equal to 0. So we can make a general rule here that whenever we have a variable sitting beside a number like that, it's always going to divide out and become 0. So our first one gives us 0 as an x-intercept solution. The next one, we're going to pull out of the bracket, make opposite sign to negative 4. So x would be positive 4. That's what would make this bracket equal to 0. So I have 2 solutions, 0 and 4 for this question. Okay, you got a couple minutes to take a look at letter C. Letter C, here is a diamond with a 6 on top and a 5 on the bottom. That's going to give us a 2 and a 3. So now I open my brackets. We have x at the front. And then I'm going to put my positive 2 and my positive 3 in my brackets. So Now I have to pull them out of brackets. What makes this bracket equal to 0? -2. What makes this bracket equal to 0? Those become my solutions to those questions. Now we do letter D. Okay, I'll give you a moment to write that down and we'll trace this right away. Okay, we're taking letter D now, and we'll see that there's a minus sign and they're both perfect squares. So I am going to square root both and open two brackets. So I'm going to get x plus 3 and x minus 3 equals 0. So this is going to come out of the brackets as x equals -3 and x equals +3. So we can write them like this, or you could also write them like this, x equals plus and minus 3. Okay, both ways are fine. Okay, a couple more questions to go. Okay, we're going to take a look at the question on the left. We're going to take a GCF out. We can all divide it by 3. And then we're going to get 25x squared minus 64, all equaling 0. So now these become perfect squares. I can square root them and open two brackets. My coefficient, my GCF, must stay attached out to the first bracket. When I square root the first term, I'm going to get 5x to start both brackets. And on the end, I'm going to get an 8. We separate with plus and minus. Now, because we have a number now in front of x, that's going to change how we solve our question. So we're going to have 5x plus 8 equals 0, and we literally solve for x. Subtract 8, 5x equals -8, and then, as we know, divide out the 5, the number in front of the variable. So for this bracket, we get -8 over 5, which means this bracket is going to give us positive 8 over 5. So, again, we get a situation where our answer is going to be plus and minus 8 over 5. Now, when we have each question, we always must have it equal to 0. This question does not equal 0, which means I have to take my 20 to the left so that it can equal to 0. Same with letter C, it doesn't equal 0, which means I have to FOIL or area box this first, then move the 3 over so that it will equal 0. So let's do that process. Get rid of our questions here. Okay, so when we remove our 20, we're going to get 5x squared plus 20x, all equaling 0. I'm going to divide out my GCF of 5x. So I have 5x on the outside of my brackets, and an x plus 4 left over, equaling 0. This one becomes x equals 0. This one becomes x equals -4. There are our solutions. This guy we had to FOIL. So FOILing him is going to give us 2x squared plus 2x minus 3x minus 3 equals 3. So now I am going to add like terms. I'm going to get 2x squared minus 1x minus 3 equals 3. Now I bring that 3 to the left. So I subtract 3 again, subtract 3 here, and I add like terms. So I get 2x squared minus 1x minus 6 equals 0. Now I do the dot on this guy. So I'm going to have a -12 and a -1 on the bottom, which is going to make my diamond become a -4, positive 3. Since I have a number in front of x squared, that means I'm going to have one of my brackets start with 2x and one of my brackets start with 1x. Because of that, all equaling 0, because of that, you need to divide one of these by a 2 and one by a 1. Again, we divide by the ones that will not give us decimal answers. So, since I divide him by the 2, I'm going to put my answer in the opposite bracket. And this guy divides by the 1, he goes to the opposite bracket. So now I'm going to solve my solutions here, which means I need to pull them out of the brackets, making them equal to 0. So that means the first bracket would be -3 over 2 equals x. And on the second bracket is going to be x equals positive 2. Remember, we're trying to find out what would make each bracket equal to 0. That would be our solution. Check your work. These are your practice questions. Push pause now and play when you're ready. Okay, you have a couple minutes to look at these. Let's take a look and see how you did. So, this one is a straight up diamond factoring to give us x minus 4 and x plus 2. All equaling 0, of course. We take them out of brackets. X is now equal to 4 and x is equal to negative 2. Now look at letter B. We need to take our 12x over. So you should get 2x squared minus 12x plus 18 equals 0. Remember, it has to be in the form of ax squared plus bx plus c equals 0. That's why the negative 12x had to sit in between both of those, because b has a variable x. Now we're going to divide out a GCF of 2. Which gives me x squared minus 6x plus 9 equals 0. When I do the diamond on him, you should have got x minus 3 and x minus 3 equals 0. That's only going to give us one solution of x equaling 3. Check your work. Letter C, we need to make it equal to 0, so the 4x is going to move to the left. So I get 2x squared minus 4x equals 0. Now we divide out a GCF of 2x. Let's redo all this. We have room. So our GCF is 2x. We have x minus 2 left over equals 0. So this means we have x equals 0 in front. Here we have x equals positive 2. Check your work, make sure you have the correct solutions. The next question is showing you an example of a quadratic. She says she has answers of negative 5 and 7. Well, that means literally you go to negative 5 here, positive 7 over here, and that is where they will touch on the graph. Now, a possible parabola. We don't know if it's an up parabola or a down parabola, so I'm just going to draw one that goes up. You could have also drawn one that goes down, so you could be like this. So either one is correct. Okay? Those are your solutions. Now, what if we had to put it back in brackets? So we wanted to create our equation. We would have y equals, x goes first always. Now, these are where they touch on the graph. Put them into the brackets, opposite sign. So the 7 will become negative 7, and the 5 will become positive 5. On the bottom here, what if the x-intercepts are 1 over 3 and negative 0.5? What might your equation be? Again, you need to math frac the decimals, because we always want fractions to work with. When we get a fraction answer, that means the bottom number was the number that sat in front of the variable x in the equation. So my equation would look like this. I open my two brackets. Generally, we have x at the front. Now, I have 1 over 3. So if I'm taking my 1 over 3, this guy's a positive 1 when he came out, so he's a negative 1 in brackets. But the number underneath is always going to go sit in front. So that's going to be a 3x minus 1. Over here, negative 1/5 or 1/2 is negative 1 over 2. So since the top number is negative, he's going to go in as a positive 1. And we're going to have a 2 sit in front of the x. So that would be our equation. Let's see how we would create an equation given our roots. Now again, that's exactly what we just did. So how do we create the equation? So always use fractions instead of decimals. The number on top is the second number in each bracket. And the number on the bottom is the number you write in front of X in each bracket. One more example. Our roots are 4/5 and -2/3. So we open two brackets. It tells us the top number goes at the back, of course opposite sides. So we're going to have a -4 here, +2 here. It says the numbers on the bottom will sit in front of the numbers with X. So here I'll have a 5X, and over here I'm going to have a 3X. So check your work, make sure the correct numbers are at the correct spots. So the top numbers go to the end of each bracket, the bottom numbers sit in front of X. This concludes lesson 3, solving equations using Xintercepts.